In today's class, we'll see some of the problems related to beta function and the gamma function. Now, using beta function, evaluate beta of p comma q is equal to integral 0 to 1 x power p minus 1 plus x power q minus 1 divided by 1 plus x power p plus q dx. So I'm going to make use of the definition of a beta function. So based on the definition, we know that beta of m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx. Now here we want a beta of p comma q. So just to replace m by p and the n by q in the definition. So therefore I'll be getting x power p minus 1 into 1 minus x power q minus 1 into dx. Now my substitution is put x is equal to 1 by 1 plus y. So differentiating this, dx will be equal to, whenever if I have x in the denominator, d by dx on 1 by x is equal to minus 1 by x square. The same thing here also I'm going to apply. So therefore I'll be getting minus of 1 by 1 plus y the whole square d1. Actually this is dx is equal to minus 1 by 1 plus y the whole square into d1. So I know x is equal to 1 by 1 plus y. So that means 1 by x is equal to 1 plus y. So therefore y is equal to 1 by x minus 1. So here I am getting dx is equal to minus 1 by 1 plus y the whole square d1. Now I am going to change the variable from x to y. So therefore I have to change the limit also. So here put x is equal to 0. So if I take x is equal to 0, certainly if I put x is equal to 0 here, 1 by 0 will become infinity and therefore y will become infinity. Then put x is equal to 1. So therefore y will be equal to 1 minus 1 which is equal to 0. So these are my limits. So therefore beta of p comma q will become, the lower limit will become infinity, upper limit will become 0, and the x I have to take it as 1 by 1 plus y whole power p minus 1. So 1 minus x. So what will be 1 minus x? So x is equal to 1 by 1 plus y. So 1 minus x will be equal to 1 minus 1 by 1 plus y. So taking LCM, I'll be getting 1 plus y minus 1 divided by 1 plus y. So that means y by 1 plus y. So instead of 1 minus x, I have to substitute y by 1 plus y whole power q minus 1. And my dx is equal to minus 1 by 1 plus y whole square into dy. So I have to simplify this. So I'll be getting integral 0 to infinity. Then my numerator will be y power q minus 1. Denominator all will be 1 plus y. So it is common. So therefore I have to, since the base is same, I have to add the power. The first power is p minus 1. 1 power p minus 1, 1 plus y power p minus 1. And here also it is 1 plus y whole power q minus 1. Then plus here it is 1 plus y whole power 2. So therefore 2 d1. And minus sign I can take outside. So this is equal to minus integral 0 to infinity. So y power q minus 1 divided by, so this is minus 2 plus 2 will get cancelled. So I'll be getting 1 plus y whole power p plus q. 1 plus y whole power p plus q d1. Actually it is infinity to 0. So when I this step also I can have it as infinity to 0. The next step I can show you how it is going to change. So this is equal to infinity to 0. So when I interchange the limit, I have to change the sign also. So now my limit is what? 0 to infinity y power q minus 1 divided by 1 plus y power p plus q. So I'm going to include, because my evaluate, I have to evaluate the beta function using beta function integral 0 to 1. So 0 to 1, 1 lies between 0 to infinity. So I'm going to write this as equal to integral 0 to 1 y power q minus 1 divided by 1 plus y whole power p plus q dy plus integral 1 to infinity y power q minus 1 divided by 1 plus y whole power p plus q dy. Okay, so my left hand side is beta of p comma q. Now I am going to take the second integral. The second integral is what? Integral 1 to infinity. Take the second integral, integral 1 to infinity, y power q minus 1 divided by 1 plus y whole power p plus q d1. So here I am going to do the substitution, put y is equal to 1 by z. So therefore I'll be getting dy is equal to minus 1 by z square dz. Now lower limit is what? Y is equal to 1. So therefore z will be equal to 1. Now if I take y is equal to infinity, z is equal to 1 by infinity, which is nothing but 0. So therefore this limit will become, when it is infinity, it is 0. When it is 1, it is 1. So y power q minus 1. Y is what? 1 by z. 1 by z to the whole power q minus 1. I can write it as 1 by z power q minus 1. So into 1 divided by 1 plus y. So that means 1 plus 1 by z whole power p plus q. dy is what? Minus 1 by z square into dz. So again the minus sign. So if I take minus sign outside and if I leave the minus sign, I have to change the limit as 0 to 1. So 0 to 1, I can take this z to the numerator as z power minus q, then minus 1 will become plus 1. And then denominator, you have 1 plus 1 by z. So taking LCM, it will become z plus 1 whole power p plus q divided by denominator z power p plus q into 1 by z square into dz. So therefore this will become integral 0 to 1 z power minus q plus 1. Then keep the denominator as it is, z plus 1 power p plus q. Then take this p plus q, z power p plus q to the numerator, it will become minus p minus q. And then z power 2 will become z power minus 2. Once again, I'm doing the simplification. So I'll be getting z power p minus 1. After doing the simplification, I'll be getting z power p minus 1 divided by z plus 1 the whole power p plus q dz. So hence, I can substitute for the second integral as is the integral 0 to 1 z power p minus 1 by z plus 1 the whole power p plus q. So therefore, my beta of this is p, beta of p comma q is equal to integral 0 to 1 y power q minus 1 divided by 1 plus y power p plus q dy. Then plus instead of the second integral, I can write this as integral 0 to 1 z power p minus 1 divided by z plus 1 power p plus q into dz. Okay. So now this y is it x or the dummy variable. Therefore, changing the dummy variable, which can be written as integral 0 to 1 x power q minus 1 by 1 plus x power p plus q. And similarly, the second also, the dummy variable can be interchange. Instead of z, I can write x power p minus 1 divided by x plus 1 the whole power p plus q into dz. So which is nothing but integral 0 to 1 x power p minus 1 plus x power q minus 1 divided by 1 plus x power p plus q into dx. So this is the value of the above integral. So you can able to solve this with the help of the beta function. The definition of the beta function will help us to solve this. Now let us see the next problem. So using the beta function, let us see how to evaluate the other integral. So express the following integrals in terms of the gamma function. Let us see integral 0 to 1 dx divided by root of 1 minus x power 4, right, in terms of gamma function. So the integral is integral 0 to 1 dx by root of 1 minus x power 4. So put x square is equal to sine theta. That means x is equal to root of sine theta. So which is sine theta whole power half, and which can be written as sine power half theta. So differentiating this, you will be getting dx is equal to 1 by 2 sine power half minus 1. Therefore, it is sine power minus half theta into d theta. Into differentiating sine theta, you will be getting cos theta. Actually, cos theta into d theta. Now let us change the limit also. Put x is equal to 0, you will be getting theta is equal to 0. Substituting x is equal to 1, theta is equal to pi by 2. So therefore it will become integral 0 to pi by 2 dx is sine power minus half theta cos theta d theta. Then 1 by 2 is also there. I can take outside, divided by root of 1 minus x square is sine theta. So x power 4 is sine square theta. So root of 1 minus sine square theta is nothing but cos square theta. So sine power minus half theta, then cos theta divided by root of cos square theta into d theta. So therefore, we will be getting 1 by 2 integral 0 to pi by 2 sine power minus half theta cos theta divided by cos theta d theta. So this cos theta will get cancelled. Therefore, we will be getting 1 by 2 integral 0 to pi by 2 sine power minus half theta d theta. And already we know that we are going to make use of the beta gamma integrals. So using the formula, you can able to write 1 by 2. The sine power minus half theta can be written as a half into root pi by 2 gamma of minus half plus 1 minus half plus 1 by 2, then divided by gamma of minus half plus 2 divided by 2, and which is nothing but this is actually root pi by 2. root of pi by 2, and therefore you will be getting root of pi by 4, and simplifying this, minus half plus 1. So 1 minus half is half. Already you have 2. So therefore it is 1 by 4. And same way denominator also taking LCM, 4 minus 1, 3. Therefore gamma of 3 by 4. So this is the value of this integral. So this integral we can able to obtain with the help of the gamma function. That means by using integral 0 to pi by 2 sine power px cos power qx dx. So we know the relation between beta and gamma function. So the relation between beta and gamma function. So this is nothing but beta of m comma n is equal to gamma of n divided by gamma of m plus n. So using this, I'm going to write integral 0 to pi by 2 sine power px cos power qx dx. So this is nothing but 1 by 2 into beta of p plus 1 by 2 comma q plus 1 by 2, and which is equal to gamma of p plus, because m is nothing but p plus 1 by 2, p plus 1 by 2, then gamma of q plus 1 by 2 divided by 2 into gamma of p plus q plus 2 by 2. So in particular, when q is equal to 0 and p is equal to n, we have substituting here in the integral 0 to pi by 2 sine power nx cos power 0, anything power 0 is 1, therefore left hand side will be 0 to pi by 2 sine power nx. So right side p is equal to n, so gamma of n plus 1 by 2, and left hand side you will be getting integral 0 to pi by 2 sine power nx dx. Right side put p is equal to n, then into gamma of q is equal to 0, so gamma of half divided by 2 into gamma of p is n, q is 0, so n plus 2 divided by 2. So gamma of value is root of pi by 2. So therefore you will be getting gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2 into root of pi by 2. Same way, the same, actually if you interchange p is equal to 0 and q is equal to n, you will be getting integral 0 to pi by 2 cos power nx dx is gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2 into root of pi by 2. So therefore, making use of this, we can able to evaluate the previous integral, because in the previous case you are getting, instead of n, here we are having minus half. Therefore, I have made use of that formula for evaluating this. So here I can write down. So using integral 0 to pi by 2 sine power nx dx is equal to gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2 into root pi by 2. So the same thing I applied here. Hope you understood this. So same way we can able to find out the value of gamma half. So we know gamma definition. Gamma of n is equal to integral 0 to infinity e power minus x power n minus 1 into dx. So here put n is equal to 2. So gamma half is equal to integral 0 to infinity e power minus x power half minus 1 dx. Now go for the substitution. Put x is equal to y square. So dx is equal to 2y dy. So limit, put x is equal to 0. So y is equal to 0. So Substituting x is equal to infinity, we get y is equal to infinity. So therefore, gamma half is equal to integral again 0 to infinity. And this is e power x is what? Y square. So here x power half minus 1. Half minus 1 is nothing but minus half. So therefore you will be getting x is equal to y square. Y square power minus half. Then dx is 2y dy. So therefore take 2 outside. 2 into integral 0 to infinity e power minus y square. And this is, you can cancel 2. Therefore y power minus 1. Y power minus 1 is nothing but 1 by y. So therefore cancelling this, you will be getting 2 into integral 0 to infinity e power minus y square dy. So this is gamma half. Now which is actually this is also equal to, if I interchange the dummy variable, I may get it is equal to 2 into integral 0 to infinity e power minus x square dx. Now making use of this, I am going to find gamma half the whole square. So which can be written as gamma half into gamma half. So for one of the gamma half, I am going to write 2 into integral 0 to infinity e power minus x square. For another one, I am going to write integral 0 to infinity e power minus y square dy. So now multiplying, I will be getting 4 into integral 0 to infinity e power, take minus sign outside, therefore it is x square plus y square dx dy. So I'm going to convert this to polar form. X square plus y square is nothing but the circle equation. By taking x is equal to r cos theta, y is equal to r sin theta, x square plus y square is equal to r square. Therefore, the converting to polar form by using the Jacobian, j is nothing but r dr d theta. Therefore, this will become 4 into, this is a double integral, and therefore here theta is, since circle, I am going to take up to 90 degree, and then this is integral 0 to infinity r value. So e power minus x square plus y square is r square. Instead of dx and dy, I can write r into dr d theta. So this can be integrated by separating d theta, then into integral 0 to infinity e power minus r square into r dr. Integrating d theta, I will be getting theta, substitute the limit 0 to pi by 2. Here for this, I go for the substitution, put r square is equal to t. So 2r dr is equal to dt. So r dr can be taken as a dt. Now limit also will be the same. By taking r is equal to 0, t will become 0. R is equal to infinity, then t is also will be equal to infinity. So 0 to infinity e power minus t into dt. So this is a 4 into pi by 2, then minus e power minus t integral 0 to infinity. So cancelling this, so into here r into dr, another 2 I'll be getting. So therefore 2 into 2 4 and 4 will get cancelled. Therefore pi into, substitute the upper limit, e power minus infinity will become 0. Then minus into power minus a plus, lower limit e power 0 will become 1. Therefore the value of gamma half the whole square is equal to pi. Okay. Therefore gamma half is equal to root of pi, because gamma half whole square is equal to pi, and therefore we are getting this. The value of gamma half is equal to root pi. Hope you all understood. We'll see the next in the next class.